We have already solved this problem in the previous video using the equations. We have calculated the maximum revenue, maximum profit, the break-even demands, also the demand for which you earn maximum revenue and maximum profit. However, those are one single number. A lot of time, it is not helpful in practical decision making. For example, I think we calculated the maximum profit occurs at just under 12,000 units. However, maybe the machine capacity is 20,000 unit or 15,000 units. So if you just know only one single number, it's not really helpful to making economic decision. So in this video, we'll show you how to produce this graph using Microsoft Excel. Now it's very simple. We're not going to use any fancy equations or calculations here. If you are not familiar with Excel, it's okay. Just following 5 to 10 videos, you will be a super expert in solving engineering economy problem using Microsoft Excel. So I copied all this data from that problem. So first thing we're going to create is something called, I call that ID column. Basically, we're going to create a bunch of data points, basically 100 data points. So I'll use a function called sequence. So if you type ACQ, then you see the sequence function comes, then you hit the tab key in your keyboard, then it will type the whole thing. Or you can manually type the sequence. That will work too. So this produces 100 data points. That's actually good enough data point to get a very smooth, nice graph. But that's not what we need. What we need is the demand. So first, so if you look at what you're trying to do here, we're trying to make this graph. So we need the demand along x-axis and all the cost and everything else along the y-axis. So we need demand. Then we also need the price per unit demand. Then we need the revenue. Then we need the fixed cost. Then we need the variable cost. We need the total cost. I'm going to type total cost here. Then we need the profit function as well. So demand, I'll start with 0. And then I'll create another thing called increment. Now, a lot of the Excel how-tos or work that we will be demonstrating, some of the stuffs will not make much sense at the beginning, right when we do it. So it's gonna make a lot more sense to create that increment cell, and you will see just in very quickly towards the end why it is so useful to produce demand like this. What you're going to do is basically you're going to produce some fake demand all the way from 0 to 25,000. Now for this problem, because you already solved, we know that the maximum value 25,000 should be good enough. But most of the problem we'll be solving later on, we don't know. So we have to increase by some guess, and we don't know. If you're producing screws, nails, you're probably producing in millions. If you're producing houses, you're probably producing in hundreds. So it depends on the scenario. So we don't know this exact increment. I'm going to freeze that. You can hit the F4 function 4 key in the keyboard. That will freeze that cell. Or you can type manually $sign before and after V. That will also freeze that cell. Keep going all the way down. So as you can see, this demand increases by 50. The advantage of that, because we don't know, if we change this, it will immediately change to whatever we need. I'm going to start with 50. I know this number is not 50. I just started that knowing that I don't know what's the max. So kind of pretend I don't know what's the max number so that later on I can show the process of how to find the max using this increment cell. So unit price is very simple. Simply is equal to 500. I'm going to freeze that because I'm going to use that same again and again. Say F4 key in the keyboard or $sign before and after B minus B, which is 0.02. I'm going to have to freeze that again, times the demand. So that's the unit price. Revenue, simply the price times unit price times the total sale or total demand. I hit 2 equal sign. All right. Now, fixed cost Simply, there's no calculation, simply that 1 million. I'm going to freeze that. Same process, dollar sign before and after, or F4 key. Variable cost is the 25 per unit demand, freeze that, times the demand. That's the total variable cost. Go down. Now the total cost, simply fixed cost plus variable cost. As you're seeing, there is no fancy formulas in Excel that we are using here. So just very simple. If you follow 5 of these videos, you will know exactly, you'll be familiar with to a level where you can very comfortably work on Excel. So don't worry too much. So revenue minus cost is the profit. Go all the way down. Now I'm going to plot all of these. So simply click on E, column E, the name of the column E, and drag all the way to K. So that will select everything here. Then you're going to go insert. We'll insert this. As you can see, this is not looking like what we have right here. So our range, we only goes to 5,000 where we need to go almost 25,000. So what are you going to do? Now we can change this increment and you'll see instead of going by 50, let's say we go by 100. Still not looking like that, but we are going to close to that. So let's say we go increase by 200. Almost close to crossing that another break-even line, but it's still not enough. We're going to do 2,500. Now you can see that it's crossing that. So the cost column, I'm going to make it full screen so I can make it a little bit bigger so you can see better in this screen. So as you can see here that the variable cost, let me grab my pen here so that I can write as well. So this orange is the revenue function, which crosses the purple line, this cost. This is revenue in 2 different points. This is here. So this is the first break-even point where profit function will cross the 0 line. So the green is the profit function, which is cross the 0 line at the demand. So the first break-even demand. Same thing here. The next break-even demand, as you can see here, the profit function is crossing. I think we calculated the second break-even is just over 21,000. And this one is just over 2,000 or something like that demand value for which you're gonna basically the break-even point. You're not gonna lose or earn anything. Now we're not done yet looking like that. So the graph, you see the unit price should be plotted in another axis because that's a very small number compared to the total cost. So what are you gonna do here? We're gonna simply write. So I think this is the where's the unit price function. So it's almost lying down on the x-axis. So simply right click on any of these graphs, unit price function or anything, then change series type, then select that unit price to secondary axis. As you can see, as soon as the unit price goes in the secondary axis, as you can see the linearly declining price function. You also need to show all the columns and are plotted where. So this is actually price per unit. And then this y-axis is for the cost, revenue, and profit. And this is our demand. Uh-oh, what happened? So this is the x-axis is our demand. Title, I'm not sure if you need any title. You can say linear price demand function or something like that, analysis. So basically very simple.